Welcome to the Digital Signal Processing lecture. Today our topic is DFT. So far we have seen how the signal behave in time domain and how they are represented in time domain. Now onward we will see how these signals can be represented in frequency domain. I have two signals, two same sinusoidal signal. One is sampled into 9 samples and the other is sampled with 17 samples. If I want to see this signal with the another perspective, that is in frequency domain, and its frequency is 100 hertz, so it will look like only one spike at 100 hertz in frequency domain with the amplitude that is here 1 with one amplitude. This signal has also the frequency of 100 hertz and it will look like same spike in the frequency domain. So frequency domain doesn't depend upon number of samples, how the signal is decomposed into how much samples. It just depends upon frequency, how much frequency signal have. In 1807, Fourier was concerned with heat propagation. He proposed a research paper. There were two reviewers at that time. One was Laplace and the other was Lagrange. Laplace accepted Fourier's work. Fourier proposed that the sinusoidals can be used to represent periodic signals, but Lagrange rejected his work. In 1813, when Lagrange died, the paper of Fourier was published. So we have four types of signals. The first one, continuous and periodic signal. Second, non-periodic continuous signal. Third one, discrete time periodic signal, and the last is discrete time non-periodic signal. As we are dealing with digital signal processing and we use mostly discrete signals, so for discrete time non-periodic signals we use Fourier series, and for periodic signals we use Fourier transform. DFT is based on Fourier series. Fourier series is that we can represent sinusoids, any periodic signal, into sum of sinusoids. So what happens in DFT? If we have an audio signal of 9 seconds and we want to store it into a device having the capacity of 3 seconds. So what we will have to do, we will have to break this signal into 3 seconds and then we consider that this signal repeats after every 3 seconds. So this was today's lecture. In the next lecture we will continue this topic. Thanks very much.